Hey, welcome everybody. We have an exciting thing to show you today. We're so excited to introduce the new FX20 from Markforged, the new latest and greatest printer. This thing is bigger, it's faster. Internally they said they used to refer to it as the beast. It's a gentle beast, so nothing to be afraid of here. We're going to show you how this thing operates, walk you through some of the new features and stuff you see, and give you a first look at this. This is one of the first FX20s installed in the United States, so we wanted to bring it to you right away and show you because we're so excited about this. My name's Rob Storleen. I'm the Application Engineering Manager here at Hawkridge Systems. I'm based here in the Brooklyn Park, Minnesota office. We have offices all over the country. We cover all of Canada and most of the United States. So a little bit about Hawkridge here is we're a value-added reseller for 3D printers such as Markforged and HP. We also have a line of scanners, finishing equipment, as well as one of the largest distributors of SolidWorks in the world. So if you've got anything in design where you want to scan all the way to printing or anywhere in the middle, just let us know because we have products in there for any step of that whole process and design. So without further ado here, let me introduce you to Jesse, one of our application engineers here at Hawkridge, and we're going to get this show going.
Hey Rob, thanks for the introduction, and thanks everyone for joining us here today. So it's a beautiful day here in Brooklyn Park, and it's been a while since we've introduced a brand new machine to you guys, so we figured we'd add a little dramatic flair to start off the summer here. So no further introductions, here is the FX20. All right, so like Rob mentioned, this thing is a monster. It is Markforged's largest printer that they've produced, and it's not really even close. So we're very excited to have this live stream here for you guys today. We figured we'd show you a little bit about the printer, give you some facts about it, how it functions, show you all some behind the scenes stuff, and then we figured we'd show you some parts and show you some things that this printer can do that no other printer on the market can do. So we'll start off just by showing you a little bit about the user interface, just show you how it functions, what the user interface kind of controls, and go from there. So if any of you are familiar with Markforged machines, you know that they're very easy to operate, very easy to control. We've got a couple of controls for our material here, for our different nozzles that we'll go over later. And then we've got some controls for things like our build chamber, our material cabinet, and our lid. So if I click on here, I could lock this and heat the chamber if I wanted to. And then we have some more fine controls here for different things that we'll go over here in a bit. So let's get right to it. Let's go ahead and start with the build chamber because that's where all the magic happens. That's where some of these great parts are going to be produced. And I know a lot of you are excited for this particular part of it. So again, just to reiterate what we've already said, this thing is a monster. It's got a big print volume. The stats on this is going to be 525 by 400 by 400 millimeters. So that's going to translate to roughly about 20.5 inches by 15.75 inches in both the Y and Z directions. So massive print volume. You can get some big parts in there, a lot of parts on the print bed. Great for some production runs here, and that's why it's kind of named the production series of printers here. So this is a heated build envelope. We've got heaters on both sides of the machine. And also this obviously is going to be an insulated machine as well. So this chamber gets up to about 200 C, which is great for some of those engineering thermoplastics, both existing and potentially down the line. So we'll go over some of the capabilities that this printer has later on when we get to those materials. Now that is going to be a hot build envelope, but what we've seen here as far as the temperature around the unit, we've really seen no more than a 5-degree increase in the more or less the immediate vicinity around the printer. So this is a hot printer on the inside, not so much on the outside. Now let's move on to, again, where the magic happens, the build plate. And what we've got on the top here is a build sheet here. So this is where all your parts are going to be printed on. This is going to be a reusable print sheet. So it's not something you throw away. Continually, you'll just keep using this. And the cool thing here is that this is actually going to be the same sheet that you use for all of your materials, all of your prints. So essentially, if you're switching between materials, all you got to do is clean the build sheet. So the main difference between the parts that you build with different materials are going to be the adhesives that you apply to the print bed. So for anyone familiar with Markforged printers, you'll recognize this guy right here, just a standard Elmo glue stick. This is going to be what you use to stick your onyx parts to the print bed. And then for some of those higher strength thermoplastics, we got Ultem here. This is going to be stuck to the print bed with some high temperature Magigoo. So essentially very easy to get the printer ready for printing. Once you've got it glued up, all you really got to do is get it vacuum sealed to the print bed. You can see all around the edges of the print bed there, we've got some vacuum chambers. So it's very easy to get this thing ready for printing, very easy to operate. And that's going to be a point that I'm going to iterate a little bit back and forth on, essentially as we go on with this machine, because Markforged has put a lot of effort into making this machine user-friendly, very easy to operate, and as much hands-off as possible. Now, if we point out the print head here, you see it's got 3 different nozzles there. Those nozzles are actually made out of tungsten carbide, so anyone in the 3D printer space knows that nozzles are typically going to be something that you need to replace as far as standard user maintenance. These nozzles right here are very, very durable, so Markforged has, again, done something to remove one of those pain points. They've made these out of a super strong material, and these are not part of the standard operator maintenance or replacement. They're not a wear and tear item, so essentially that's just one less thing that you kind of have to worry about when operating the machine. And then in the back center of the unit right there, you can see some brushes, and that's going to be called the wipe station. And whenever the print head needs to clean itself, it will move to that wipe station, just give itself a little bit of cleaning, and then you'll keep printing. So again, one more thing Markforged has kind of done just to remove the hands-on time that you have with the machine in terms of maintenance and operating it.
So this is interesting, Jesse. The build sheet is one build sheet. Doesn't matter if we're building high temperature or standard onyx.
Correct.
And the nozzles aren't replaced as a normal maintenance type item.
Right.
The nozzles are built to last with a lot of mileage.
Yeah, exactly.
That's incredible. Yeah, you know, you look at some systems out there, you're looking at different build sheets for different temperatures so you don't melt them to the table.
Right.
Where here we're basically just changing the glue on it.
Right. And then you just wash it in between and you're good to go. Very, very quick process and very, very straightforward, right?
Yep, fantastic.
So we'll get one last look at that big build chamber. I know a lot of you are interested in that, but what we're going to do now is we're going to move on to the materials. This is where your material is going to feed from. It'll be on the bottom of the machine here. And what we'll do is we'll go ahead and unlock that guy real quick. There we go. And this is where all your material is going to feed from here. Now, what you're going to see here, you see 2 different spools here, 2 larger spools, and then you got this little miniature guy right here. Now this is actually not a miniaturized spool. This is going to be your standard spool of onyx that works with something like your desktop or industrial line of printers, 800 cubic centimeters of material. So it definitely gets a few parts out there. Now, with a bigger printer does come bigger spools here. So we've got 2 different spools here loaded for you today, just to show you a quick sneak peek of the materials and the actual parts. So what we've got here is we've got a spool of Ultem 9085, and then we've got a spool of support material that holds up any Ultem geometry that may be at too steep of an angle to print when it's layer by layer printing, or maybe it's overhanging over nothing and it needs to be held up by some support material. This is easily removable after printing. And again, this works with Ultem here. And now these spools, both of them, are going to be 3,200 cubic centimeters. So that's why this kind of looks so small, because it's literally a quarter of the size of all these different material spools here. So this is something that's really cool. If you've got a Markforged printer and you have some of these spools, these onyx spools, you can use these smaller ones with this printer. So let's say you have some backstock and you want to just throw one of those small ones in there, you can absolutely do that and not use one of the bigger ones if you don't want to.
All right, so I got a question here come in, Jesse.
Yes, sir.
What are the white bags for on the side?
Yes, so onyx is a nylon-based material, so it is susceptible to absorbing moisture from the air, and to an extent so is Ultem and its support material. So these are desiccant bags, so in this chamber you've got some airflow, and these desiccant bags help control the moisture, keep your material dry throughout the entire spool, and keep your parts looking great.
All right.
All right, so as the material flows, it goes all the way around the unit there, flows all the way up through here, and let's go ahead and get into the lid here and look at the brains of the operation, look at some of the things up here. So the material flows here, and as we're following it, I'm going to stop and point out the carbon fiber spool that we've got inlaid here. So this is going to be adding some continuous strands of carbon fiber to your onyx parts. Those of you familiar with Markforged's printing process know that it can do that. But a very cool thing we're excited to announce and talk about today is that you can also inlay your Ultem parts with continuous fiber. And we'll get to that here, how that works for those of you who aren't familiar. But this is where all that carbon fiber comes from. And as we move on to the top of the print hit here, we're going to take a look at a few of the things here. So this is a belt-driven system. You've got a belt here, and this is one of the things that you'll be checking periodically every couple hundreds of print hours. essentially it's a very easy process to do. That is one of the user maintenance items, but it's very, very straightforward. Now, as we move to the center of the volume here, we're going to look at the top of the print head here. So you can see that it's got a couple different modules here. It is a modular system, and they're each labeled with different letters. So we've got the A module on the furthest left. That's going to be for your modeling material, the main body of your part. So your plastics like Onyx and Ultem 9085. And then as we move on to the right there, you're going to see the F module. That's going to be things like your continuous fiber, like I just mentioned. Those will be inlaid continuously into your part. And then the B module, that is going to be the support material, like I just showed you guys for the Ultem parts, just to hold up some of that geometry if it needs it. Now, I hear a lot of the gears turning in some of your guys' heads. You hear the word modular, and you're thinking, okay, well, I'm going to have to be in here changing out different modules for different materials, right? Oh, if I want to switch to Ultem, I'm going to need to change out that A module, right? Well, that's not the case, and that's actually one of the cool things that Markforged, again, has done just to keep this as simple as possible. Every module stays there, and you don't need to change out anything for any different materials or anything like that, which is really cool. And again, one more thing that Markforged has done to keep this pretty straightforward and easy for you guys.
Yeah, so kind of just to reiterate too, those nozzles, if I'm changing slice thickness,
Yep.
if I'm changing material, there's no changing of nozzles on this. I just load the new material and go. I select my slice thickness in Eiger,
Yep.
send the part to it, and off we go.
Yeah, correct. Yeah, Markforged has done it so that if you want to change your thickness, this can get down to some really fine resolution parts if you want, or some really faster resolution parts if you want. You don't need to change out your nozzles that I just showed you, or the print head modules, anything like that. That is all controlled by Eiger, like you mentioned. And if you guys want to try out Eiger, it is a free software. To feel free to go ahead and sign up and just see how easy it is to use for yourselves. Don't just take our word for it. But it's all controlled by that one software that now encompasses the FX20. So if you're familiar with that software, you'll just be using it for this particular machine as well.
That's a good point. Is Eiger, that's developed by Markforged for their systems, will work on any of the desktop systems, the industrials,
Yep.
the Metal X system,
Yep.
the FX20. So once you're familiar with the software, which it's very simple to use, it's the same platform throughout everything that they do.
Right, yeah, exactly. And as far as the bed and everything, speaking of slice thicknesses, the bed is also self-leveling, and essentially as long as the machine does not move, the level will stay in place and you don't need to level the bed. It will calibrate itself, right?
Right.
Yep.
Okay, so we did get a couple questions in. One thing I kind of missed when we started out here is, since we are live, throw questions into the chat. We have our application engineers and a few salespeople sitting and watching the chat. They're feeding me questions live. So if there's something you want to see, let them know. They can forward those on to me and we can kind of address it a little bit more. So let's I got a couple questions here real quick. The lower conditioning cabinet, is that pressurized or anything? Is it sealed? How does it keep the material dry down there?
Yep, so it is sealed and it does have some airflow into it that circulates. So essentially those desiccant packs, you'll change them out periodically just to keep them fresh. But like, as you saw, it's very easy just to kind of unclip them and install some new desiccant packs. So that's kind of how it keeps those materials dry down there.
Yep. Another question came in from Matthew is, the heated chamber, does it have a cool down time after we build a part in Ultem, or can we remove it right away? It's kind of an interesting question. We installed this machine this week. We were so excited to get this out that we got this in, we installed it so we could be ready for this live stream today. We've been playing with it this week, running some jobs. I can pull a part directly out of it when it's done. It shouldn't hurt it at all. What I'm thinking in my own head is, if I've got, say, an Ultem part in there that's really hot, I may not want to shock it coming out. Let's say it's a small, thin part. My feeling is we're going to have a potato chip when we get done. So we can go in that case and hit cool down and just let the machine come down in temperature, so when we remove the part, we're not shocking it. So to be honest, here's the real answer is, we haven't tried that yet, but we can remove a part directly out of it. I'm just thinking certain geometries we're probably might want to cool it, and we can do that too.
Yeah, so if you need that part right away, it might be a little hot, but you can definitely pull it out right after it's done printing.
Right. So another question came in is about installation.
Sure
so
thing.
what does it take to install something like this? Is this something a customer installs? What's required in order to install it, and how long does it take?
Yeah, so as far as installation, that's something that we would help you with. It's a very simple in terms of facilities, so I'll bring you guys back here just to point out some different hookups here. And there's not really a whole lot to it, but I'll show it here, you guys, anyway. So on the far wire here, we've got the electrical hookup. This is something your electrician would do. This is a 200 to 240 volt range, and then it's also a 3-phase power supply as well. So that's really the main hookup, and then we've got the closer cable. This is your standard LAN cable, really nothing special to that. They decided to go with LAN on this machine because as you get bigger parts, depending on the resolution you export them from CAD, you might have some bigger part sizes in terms of the actual file itself. And so the LAN cable is just a much easier way to get those jobs from your Eiger slicer to the machine itself. And you can also export them via USB as well. And then in terms of the rest of the facilities, like I brought up, there's really no need for any sort of ventilation. The machine doesn't really get that hot around it. And Rob, I know we've kind of done some testing in terms of the noise, the ambient noise, right? When it's fully operational, it's got that oven on. And we're really only seeing something like 65 decibels just in the immediate area surrounding the machine.
Yeah.
So.
Well, we're running right now, and we're able to talk around it, so it's not creating a lot of noise. We also, just for curiosity's sake, hung an environmental recorder in the back to measure temperature and humidity. And I think with this thing running Ultem all night long, we don't have the biggest room here, so it's not like we have this huge volume.
Right.
And I think we saw like a 4-degree increase in the room here.
Yeah, not a lot at all, right?
Not a lot, so it's not like we're going to cook this room up by turning on that oven. It's insulated really well.
Yeah. Now, in terms of installation time, that is a great question. Kind of what we've seen so far, it really takes no longer than half a day for one of our guys to get this installed. Essentially, once it's hooked up to the power, the big thing would be leveling the feet under the machine. And then leveling the print bed, getting that all calibrated and everything, making sure that it's level, because like I said, once that is level, you don't have to do that again. Just one more thing removed from the user maintenance there. And then once that's done, we get you up and running with a part, come back the next day, check up on you, just see if there's anything that you need, any other questions, get you trained on Eiger, on the machine. So really, from what we've seen, no more than a day, right?
Yeah.
To get this installed.
Biggest thing is power. If you got power and a LAN connection, we're pretty much ready to go.
And then once you're good to go, you can start printing parts of your own. So a lot of you are probably thinking, "Where's the parts? Show us the parts." So let's
take a look at the parts.
Move the parts, right? All right. So what we've gone ahead and done here is just to start off. Numbers are great. We brought up those numbers of the build volume earlier, right? But we've printed a few example pieces here just to show you guys the differences of kind of the different lines of printers and the different capabilities here. So we'll start off with the desktop series of machines. This is going to be something like your Onyx 1, your Onyx Pro, your Mark II. Like the name of the series implies, these are small machines, small footprint. They go on your desk. Rob, I know you have one like right next to your phone, right?
Yep, it sits right next to my desk. I'm on meetings all day long.
Yep.
That little guy's just sitting over there printing away.
Yeah. And then we move up here. So maybe you need a little more speed, a little more print volume, because some parts are limited by that. So then we've got the industrial series of machines. These are going to be your X3, your X5, your X7. We love both these lines of machines. The X7 in the industrial line has been my daily driver for years. Fantastic machine. They're both capable machines, produce great parts, as you can see here. But then let's move on to the next part here. So as Rob mentioned, we just got this machine up and running a few days ago after the installation. So essentially we've been getting some parts here for you guys, but we wanted to show you just a quick little visual comparison because numbers are great, like I said, but sometimes visuals do speak for themselves. So this is going to be, again, a 3D representation of the full build volume of an X7 machine. The maximum height that this machine can get to is 200 millimeters, and like you heard earlier, the max height for the FX20 is going to be 400 millimeters. So literally double. I could fit easily 2 of these build volumes, if not 3, if I broke them up or more. So we've really kind of progressed in terms of the amount of capabilities that it can do, and in print times as well, right?
Yeah, so when you look at the progression here, right, the desktops came first.
Yep.
Fantastic little machines, economical, they're quick, they build incredible looking parts and strong.
Yeah, absolutely.
Some of the models are capable of putting carbon fiber and stuff to make them even stiffer. And then when you move up to this industrial series, we're going a little larger, few more materials available, more speed, so we're seeing that progression coming up.
Yep.
Just as a comparison, the little cards on the front here are showing that this small one on the desktop machine. That was a little over 2 days of build time.
Yep.
At the highest slice thickness that we could get on that machine. When we moved up to the industrial machine, ran the same part, just blew it up to the size that we can build. Here we've got a larger part, and we're coming in at about 1.5 days build time. So we've cut the build time in half as these machines progressed. And again, you know, this desktop machine is nice. It sits in your desk, it runs in the background, economical. We see print farms where there's, you know, 30, 40 of these machines set up to get productivity out of them. Then you come up and say, okay, we want a little bit bigger part or more speed. All of a sudden we go into industrial.
Yep.
Now, what the excitement is all about is we get up to this FX20.
Yep.
We did a little time test on it. Since we didn't have time to build the entire envelope in this part, that part built in here would be, what was it, 21 hours?
Yes.
So here we're building a full envelope of X7 in 1.5 days. We're doing this much more volume in only 21 hours with the FX20.
It's impressive, right? Just the amount of space that this machine has and the fact that it could do the equivalent of this, but the full build volume, but faster.
Right.
So you see, like you said, the progression of how we've moved, the capabilities, the bigger print volumes, which can produce some really, really large and great parts, right?
Yeah, and I look at it as, you know, I love the idea of big parts, because how many times have we had to section something because it wouldn't fit into an envelope?
Yep.
Here we've got no control over, or we have more control over that. We can do bigger parts without having to slice them and cut them and rebuild them. The thing that really impresses me here from the years I've been in the industry is more the speed.
Yes.
And I like big parts, that's great, but I'm looking at speed increase here and I'm thinking, okay, maybe I don't have big parts, but I'm building fixtures for the factory floor, or I'm doing some prototypes for a design we're doing. You know, we always kind of laugh about fail early, fail often.
Yep.
And we all know that if we fail, we're going to learn from it. And if we can get another iteration quicker, we're going to keep reiterating. And generally, your product at the end is way better because you've found all these errors early on.
Right.
So speed to me is like the king. I like the big size, but man, speed. If I can get that much speed out of it,
Absolutely.
I'm seeing a huge gain there.
Yeah, so speaking of speed, we've got a couple parts here. Like I said, what would the show be without some parts to show you guys here? So we've got a GPS sensor mount here. This is going to be close to the max size of the FX20. Not quite there, it's got a couple inches to go. This is about 800 cubic centimeters of material, and that prints in about 15 hours. So again, next day parts, you print it overnight, it's there, and if you need to iterate, like Rob said, it's done. And this is the actual size of the application, so I'll move this over here just to show you the obvious visual comparison. Not only is it too wide for the X7 build volume, but it is clearly too tall here as well. So size and speed come with this machine, and it's a really great machine so far. So we kind of wanted to do a little bit of a comparison here. So what we've done is we've taken this same sensor mount, and we'll bring up a quick comparison here, and we've taken that part and shrunk it down to the maximum height that the X7 could print at. Like I just mentioned, that's going to be 200 millimeters, right? And just to keep things fair, we did the same with this part. We took that same shrunken down version and then we put it on the FX20 just to see how fast both of those would print, right? And as you can see, the X7 version takes about over 8 hours, and then we've got about half that on the FX20. So just taking the same part and doing nothing else and putting it on the FX20, you've gained just about half a day, right?
Yep. And seeing's believing, right? Because we're told way faster, which is great. I want to see it myself, and we're seeing it. One of the questions just came in from Brandon is, to achieve that speed, is the layer height the same as the part print on the X7? And it is. So we printed this in turbo mode on an X7. We went in and took the large envelope size from the FX20, same part, scaled up to that size with the turbo mode on it, and that's how we were achieving that 21 hours versus, 36 hours on the X7.
On this guy,
So, you know, as we're progressing along, these things are the things that are getting us really excited. Is we can be given numbers, but we're actually seeing this, and as we're building, we're seeing these gains.
Yep, and we spent a lot of time kind of using the FX20 and Eiger, just seeing those cool print time increases. So we did also, just to give you guys another example of those increases in speed, we took this same part, the X7 build volume, did nothing to the part, and then just put that onto the FX20. And we found that that print time with the same part, same turbo mode like you mentioned on both machines, goes from about 36 hours down to about 8, right?
Yeah, down to about 8.
So. Yeah, Markforged in their testing and kind of getting this machine up and ready for prime time has seen that you can get up to about 5 times faster print speeds, depending on your geometry. That's always kind of the thing with the 3D printing, right? But from what we've seen at the very least 2x speeds increases for most of the things we've looked at, up to 4 or 5. So we don't think that that's unreasonable, right?
And that's part of the reason why using the same geometry to compare times is valuable.
Right, exactly.
Okay, so I got 3 parts here.
Yep.
Let's talk about these a little bit.
Perfect. So what we've got here is we've got 3 of the same equivalent part. One of them is paused in the middle, and we just took it off the print bed. We'll go over that here in a little bit. But we'll start with the thing that most of you are probably excited about, and this is going to be the Ultem 9085 part. So what this is a tray table bracket for a tray table that goes on an airplane. So essentially, this is going to be a material that's going to be rated for aerospace applications. It's flame retardant, and it's self-extinguishing. It's an engineering thermoplastic. It's very, very strong. And it is, Rob, you were telling me that it's widely used in aerospace applications, right?
Aerospace and any kind of transportation.
Yep.
When you look at Ultem, high temperature, high strength, high weight to strength ratios. With the V0 rating on it, we have no flame, we have no toxic fumes, we have no gases and that kind of stuff coming off it if it were to ignite. So it's required in certain applications like airplanes. You know, if you had a fire on board, the last thing you want is toxic fumes and smoke and whatever. So this is widely used, especially around aerospace and into airplanes.
Yeah.
If you get on a commercial airliner today, it's been built in the last few years, there's probably some Ultem parts that are printed on there. Most times what you're seeing is ductwork, clips, stuff underneath the skins. It's not sexy stuff, but yet it's taking weight out so they're not having to fabricate aluminum or metal or whatever.
Sure.
Because this meets those requirements.
Yeah, so we're really excited at the properties that Ultem brings, and we're really excited to see what our customers do and the applications that honestly it opens up for our customers who have these. Because like I said, it's rated for aerospace, it's already in use, it's already proven out and certified. So we're very, very excited to see how that works for our customers who use these machines and this material here. And so how Ultem works here, I'll bring this part here into focus once again. We've got the part here itself, and we've got an example of the support material that Ultem prints with. I'll just bring this up. And so how this works is, like I mentioned, if you do have geometry that needs to be held up, then the Ultem support will hold that up. And it's very, very easy to remove after the fact. When we printed this part, Ultem is pretty widely known for having supports that are a little bit easier to remove when they're warm. We had this part cold for quite a while, and it peeled off the same way. So very easy to remove. It's not something that you need a whole lot of post-processing equipment for or anything like that, correct?
Correct, exactly.
And then as we move on here, we've got an onyx equivalent here. So again, you can print in onyx on these machines. So we've got an example of the same part here. With a different comparison here, you see obviously that it's got a little bit of a matte finish versus the sheen of Ultem here. Kind of depends on your preference, which one you like the look of better. But let's go ahead and move on to what we're kind of really excited about in terms of capabilities of this printer, which is the continuous fiber reinforcement. So this is the same part, obviously. I've stopped it here pretty early on just to show you an example of. If you follow the perimeter here, you see this continuous strand right here, and that's going to be those carbon fibers that I keep pulling up here. So the advantage for having a continuous strand that goes all the way around the perimeter versus something like it's just chopped and randomly placed is that if you put the part under strain, so this one would be just bending in 2 different directions. So if I bend it, the tension, the actual strand would be placed in tension. And for anyone familiar with carbon fiber, either through the Markforged printing process or just in general applications, that's how you place it, a lot of the strength onto it. And that's where it gets a lot of those strength from, is being under tension. So you can do that. You can replace the walls of it with carbon fiber, or you can replace an entire layer with a different pattern of carbon fiber as well, depending on your application. So Onyx and different parts from the Markforged printing process have been able to do that for years. We see some aluminum replacement equivalents just out of a composite printer from something like any of these lines that we've talked about here today. But then we have now the ability for Ultem parts to be inlaid with continuous carbon fiber. So you've got those great properties of Ultem, right? And then you can inlay those with some continuous strands, just really get strength from those Ultem parts that just wasn't possible before.
Right,
Yeah.
right. So that's what's exciting, is this is very unique to Markforged, being able to lay carbon fiber and inlay in, and now to be able to do with Ultem.
Yep.
Wow, the sky becomes the limit.
Yep.
Okay, I got a couple more questions that came in here. Will they do an update to allow printing with Kevlar?
So that's something that they're talking about. So essentially what they're doing is they're starting out with carbon fiber. If you guys got a use for that, then Markforged is always open to feedback as far as being able to print with different materials. So that's definitely something that if you want that to be done, just let them know and they can look into that.
I got a feeling that it's sitting in their roadmap. They don't clue us in a lot on what's coming down the road, but I can't imagine that wouldn't be something on there. And like Jesse says too, as if it's something that is required or you're looking at, it'd be a suggestion for them to say, yeah, let's see what it takes to add that into this machine. Another question come from Brandon. This is an interesting one. I'll address it straight to Brandon. He's wondering if we've had a chance to measure this to see if we're seeing the same accuracies and stuff that we've always seen on the Markforged products.
So we haven't measured that exact part, right? But Markforged has done their work in terms of getting the machine dialed in, and they've seen some increased accuracies between these particular lines. So as we move down the lines, the machines get more accurate, and that kind of still stays the same way with the FX20.
Yep.
So Markforged does have data sheets on that, so feel free, we can link those in the chat if you guys would like, that we can show you guys for those.
And to Brandon, you know, if you're seriously looking at this, let us know, right? If you've got a benchmark, we now have systems up and running. We can benchmark. So if you want to do some testing and looking and measuring accuracies, by all means, just let us know and we'll get a benchmark out to you and you can kind of check that out yourself. You know, it's usually best when you see it yourself, and especially in a geometry that is your geometry and something that you're, you know, using, as opposed to me just picking something out of the air. So fantastic questions.
Absolutely.
Let's see what else we have here. Is the nozzle diameter the same as on the X7?
That's not something that we've had a chance to measure, but that is something that Markforged is working on and getting their technical data sheets all built out.
All right. So it looks like the questions coming in here have kind of slowed down a little bit. So not to keep you guys too much longer, we're going to let you guys go. Our AEs will be online here for a little bit longer, so if you have questions, make sure you ask them. If you want data sheets and stuff, just supply them with your information and they can get back to you with that, or they'll supply it right there online. Before we go to, one little plug I need to do is we've got some events coming up called Hawk Tours. We're spacing those out around the United States and Canada. They're going to take place over July and into August. We have 23 different locations identified around the country. Some of them are at our DMLs, our digital manufacturing labs, similar to this. So we'll have one here on July 7th. So if you wanted to come in and see the equipment, you know, it's an open house type format. We'll have scanning represented, we'll have SolidWorks represented, we'll have 3D printing represented. So it's a really nice chance for you to come in and see all of our products. So go to our website, look for the events page. It'll show you the different locations around. If there's one near you, please register, go check it out. It's a great chance to meet everybody from Hawk Ridge, share information, and see what we have to offer. So with that, we're going to let you go. Like I said, the guys will hang on the line a little longer to answer questions, but thank you for coming, and thank you for giving us a chance to show you this fantastic machine that we're so excited to show. So thanks for coming.
Thanks, everyone.